right, welcome, and we're moving on into grade 11 and into grade 12, and we're continuing at that level talking about redox reaction. In other words, reduction, oxidation reactions. Okay, but specifically today, we will be having a look at what we call the electrolytic cell as opposed to the galvanic cell. Now, listen very carefully, because there is always a confusion with learners around what is a galvanic cell and how does it differ to an electrolytic cell. So check carefully as I take you through this so that you don't have that confusion anymore. An electrolyte, in the first place, let's define what this is. An electrolyte, and both galvanic and electrolytic cells will have electrolytes. They function through electrolytes. An electrolyte is a solution that consists of ions that are free to move. Okay, so ions that are free to move, like a copper sulfate solution, it's an electrolyte. Zinc chloride is an electrolyte. Potassium nitrate is an electrolyte because it has got ions that are free to move. Okay, and as they move, they can conduct electricity. Okay, electrolysis, on the other hand, which is something you must understand here, electrolysis occurs inside an electrolytic solution. So when we talk electrolysis, we can't have electrolysis occurring anywhere else. We need to have an electrolyte for us to have electrolysis happening. And what is electrolysis? Electrolysis is the breaking up of an ionic compound by means of electrical energy. So you make use of electrical energy to break up ionic compound. Remember what I said in the previous lesson about energy being released when bonds are formed, and when you break bonds you need to supply energy. The same thing is happening here. So you're supplying energy in the form of electricity, and then you cause ionic compounds to break, and we call that electrolysis. Okay, now an electrolytic cell, now we're coming to what this thing is. An electrolytic cell is a cell that converts electrical energy into chemical energy. Okay, so you bring in electrical energy and you use that to break up ionic compounds. For example, here is one electrolytic cell. You would see here we are supplying energy. This is a battery. Okay, positive and negative terminals. Okay, and then if this is negative, connected to these electrodes here, this electrode here is negative because it is connected to the negative terminal of the battery. This one, on the other hand, is positive because it's connected to the positive terminal of the battery. Okay, now let's check what happens in here. Inside here I've got a molten solution of sodium chloride. When it is molten, it means in this solution I've got sodium ions and chloride ions. The sodium ions are positively charged. So because they are positively charged, they will be attracted to the negatively charged electrode. Remember, this is negative because it's connected to that negative terminal of the battery. So the sodium ions are positive, they will be attracted there. This electrode is therefore the cathode because it is attracting the positive ions to itself. It is attracting the cat ions to itself. Hence the name cathode. Okay, cat. All right. But then, to be simple, we define this electrode, or we call this electrode here a cathode, because this is where reduction occurs. Okay, simple as that. On the other side, we see the negatively charged chloride ions attracted to this electrode here that is positively charged. Okay, so attracted there, it is positively charged, so it will attract the negatively charged ions in solution. Negative ions attracted there, negative ions are N ions, and this electrode here, it's called the anode because it attracts the N ions. Okay, so it is the anode. In that way we know what it is. but simply defined within redox terminology, we call the anode the electrode where oxidation occurs. Okay, oxidation occurs. Now, how does that oxidation occur now? Let's look at it. The chlorine atoms or chlorine ions going in there, they lose those electrons to be chlorine atoms, okay, and then electron is gone. But chlorine, it's a diatomic molecule, so we'll have another chloride ion losing an electron to become that, so that the two can give us the Cl2 that we need. On the other side, what is happening? Those electrons get in there, come to this side. On this side, the sodium ions receive the electrons to become sodium solid. So you can see this is reduction, gaining of electrons. Okay, gaining of electrons. This is oxidation, losing of electrons. So that is what is happening there. Let's meet on the next section of this lesson.